Okay. Now we are discussing about frame of reference. We are having two types of frame of reference. Two types of frame of reference.
Okay.
What is the first one? Inertial frame of reference. What is the name?
Inertial frame.
Inertial frame of reference. And second one is non-inertial frame of reference. Second one is non-inertial frame of reference. What is the inertial frame and what is the non-inertial frame? Which system acceleration is zero, that is called inertial frame. What is the meaning? Which system acceleration is zero, that is called inertial frame. For example, on bus is at rest, passengers sitting in the bus. Bus is at rest means acceleration zero. Bus is moving with uniform velocity means acceleration zero. That is called what? Inertial frame of reference. Understand now? Similarly, for example, on bus is moving with some acceleration. That is called what? Non-inertial frame of reference or accelerated frame of reference. Is another name what? Accelerated frame of reference. Accelerated frame of reference means what? Acceleration not zero. Some acceleration having. Okay, what is the difference between this and this? In this, Newton's laws applicable. Newton's 1 to 3 laws applicable in the inertial frame. But in this non-inertial frame, Newton's laws are not applicable. Okay, now? So in this, what we are taking force, F equal to ma taking. But in this, we are not taking F equal to ma. Understood? So we are doing some correction. What is the correction? F equals to ma minus ma naught. What is the ma naught? Ma naught is the plus adding, plus ma naught adding. Depends upon the direction is the same. If you take plus, if opposite minus you take. Understood? Ma naught is called pseudo force. What is the name?
Pseudo force.
Ma naught is called what?
Pseudo force.
Pseudo force or fictitious force. Fictitious force or pseudo force. Remember pseudo force enough. Pseudo force means what? Not real force. So F equal to ma in the inertial frame applicable. In the non-inertial frame not applicable. F equal to ma plus addition doing some. What is that? Pseudo force. Understood now? Definitely it is opposite to. So minus taking that things later. When you are doing that, we are understanding. Once is here, for understanding this, for understanding a pseudo force, I am making one example. For example, this is one lorry or truck. It is moving with some A acceleration. What is the acceleration? A acceleration. This surface is smooth surface. On this I am keeping one block. What is the mass of the block? M. What is the mass of the block? M. So when it is moving like this, opposite direction one force generating. That force is called what? Pseudo force. This acceleration why coming due to engine. Engine is exerting some force with the general electronic system. Due to this motion of the system, reverse another force generating. That is called pseudo force. So reverse what happening? Some acceleration coming. What is the acceleration? A naught. Here A equals to what? Minus A naught. Magnitude same only but direction opposite. Due to that what happens? This block moves with A naught acceleration. Opposite direction. Now what is the pseudo force? Minus ma naught. What are we taking? Minus ma naught. Understood? This is called pseudo force. Pseudo force is denoted with Fp. Is it clear now? So that is pseudo force. Pseudo force is generated only in the non-inertial frame of reference or accelerated frame of reference. Quick. Okay, next we are discussing about motion of a body on an inclined plane. What is the name? Motion of a body on an inclined plane. Is it motion of a body on a inclined plane? See, before going to this, first we discuss about horizontal plane. On the horizontal plane, I am keeping one block. What is the mass of the block? M. At the time, mg acting downward, vertically upward, some normal reaction etc. Perpendicular to plane of contact. That is called normal action. Okay, now? If the plane of contact is horizontal, perpendicularly comes. Clear now? So before going to this, you go to friction. What is the name? Friction. What is the friction? Friction generally wave generating. If you observe any surface with our eye, the irregularity is not possible. Surface is not smooth. If any smooth surface appearing also, that is not smooth. With the help of microscope, if you observe some irregularities happening, due to that only one surface is on the other surface, interlocking occurs to the surfaces. When you are applying some force, frictional force generating. When you are applying force, then only frictional force generating. If the applied force is zero, frictional force zero only. Interlocking happened, friction wave generates. If you apply force, that happen. Understood now? So that is the main cause for friction. So here, mu is the coefficient of static friction. Mu is the coefficient of static friction. What is the mu? Mu is called coefficient of friction. What is the name? Coefficient of friction. Okay, now before going to this, you observe one graph. This is x-axis, this is y-axis, and this is the origin. This is the applied force, and this is the frictional force. What is this? This is the frictional force, and what is this? Applied force. So this graph is like this. Just to remember this graph. So up to here, what is this? Straight line. Straight line represents what? Up to here, F is proportional to F. Proportional represents what? Straight line. So up to this is called static frictional force. You take this is O, this you take A, this you take B, this you take C. What is the O to A? O to A, what we are having? Static frictional force. What is this? Static frictional force. Okay now? So at A position we are having some FMS. FMS means maximum static frictional force. FMS means maximum static frictional force. This is only called FL also suppose. FL means what? Limiting frictional force. Both are same one. Limiting frictional force. What is its name? Limiting frictional force. So this corresponding B position where it's sitting on a y-axis, that is called FK. FK is called what? Kinetic frictional force. What is the FK? Kinetic frictional force. FK is called what? Kinetic frictional force. So O to A is called static frictional force. A position is called FMS, limiting frictional force or maximum static frictional force. And B position is called what? Kinetic frictional force. From B to C it is constant. So when one body is moving on the surface, what friction, which kind of frictional force existed? Kinetic frictional force existed. That is constant. Understood? So what is this FMS? FMS means what? Maximum static frictional force. For example, I am keeping one body on the surface of another body. I am applying some force. We are applying some force, not moving. We are applying some increasing force, not moving. For example, I am assuming 100 newtons is the maximum force. After 100 newtons, if you apply, it is sliding. I am assuming. So 0 to 100 newtons. 0 means what? Is applied force 0, frictional force 0. Like the gradually increasing. For example, I am assuming maximum force is 100 newtons. I had applied 20 newtons. Same 20 generating. This is called static frictional force. 30 applied, 30 generating. 98 newtons applied. 98 newtons frictional force generating. What is the maximum force? 100 newtons. 100 applied. At that time it is ready to slide. Next what I am applying? 100.05 I am applying. It slides. When it is sliding, some frictional force is existed in between that body and the surface. That is called kinetic frictional force. Clear now? Similarly, one body is rolling on the surface. At that time existed force is called what? Rolling frictional force. What is the name? Rolling frictional force. These all are the various kinds of frictional forces. Quick. Okay, see here. Here, what is the FMS? Maximum static frictional force or limiting frictional force. So that is proportional to normal reaction. For example, here I am keeping one block. Here I have applied some force. It is creating some frictional force. Then I am assuming FMS. Created frictional force is FMS. FMS is what? Limiting frictional force. So FMS is proportional to normal reaction. What is the normal reaction? Mg. Is it clear now? So by removing this, what I am getting? For example, I am removing this proportional. At the time, what I am getting? Proportional constant. What is that? Mu s. What is the mu s? Coefficient of static friction. What is the name? Coefficient of static friction. It depends. What is the coefficient of static friction? It is fixed to given material. Understood? It's some changes, small changes. Depends upon the some dust particles existing. Understood? Like the atmosphere conditions, temperature changes, like that things. What happens? Slightly changes. That is about what coefficient of static friction. For example, what is the maximum static friction force? Mu is into normal reaction. So from 0 to FMS, I am applying some force. What I am applying? Applied force. How much you had applied? That is proportional to static frictional force. That is called Fs. What is the name? F is proportional to Fs. Within the applied force is 0 to FMS limits. For example, maximum static frictional force by using formula mu is into normal reaction, I had got 100 newtons. Understood? I had applied 20 newtons. 20 newtons only friction force generating. 30 newtons, 30 only generating. 100 applied, 100 only generating. Understood? That is called what? Static frictional force. That is self-adjusting force. It depends upon the applied force. Applied force, how much is there? Exactly equal. Here proportional, but that is not proportional. Exactly equal to applied force. 100 newtons FMS I had taken. 80 newtons I had applied. Static friction force how much? 80 only. No proportional. Exactly equal. So, static friction force is called self-adjusting force. What is the name? Self-adjusting force. So, what is the Fs? Fs is called. What is the Fs? Fs is called self-adjusting force. This is only called what? Static frictional force. Static frictional force. For example, maximum static frictional force 100 newtons applied. 0 to 100, that is applied force equal to static frictional force. That completed. 100 newtons is the maximum static frictional force. 100.05 newtons I had applied. There is more than 100. Due to the what happens? Body sliding. When sliding in between the surface and the body, also friction force is there. That is called kinetic frictional force. That is constant. That is constant. Whatever static frictional force changes. Whatever maximum static frictional force fixed. Depends upon mu is into n formula. So what is the Fk? Fk is called what? Kinetic frictional force. Kinetic frictional force means when body is sliding on the surface, at that time existed frictional force is called what? Kinetic frictional force. So in this case, also Fk is proportional to n. What is the Fk? Fk is called kinetic frictional force. Fk is proportional to n. I am removing proportional. Then what I am getting? Mu k getting. That is a proportional constant. Okay, now what is the mu k? Coefficient of kinetic friction. What is the mu k? Coefficient of kinetic friction. Understood? Quick. Similarly, for example, one wheel is rolling on the surface. At the time, what is the frictional force? That is called rolling frictional force. So, compared to maximum static frictional force, static frictional force, kinetic frictional force, rolling frictional force is very less. Due to that only, in the case of motion, what we are using? Rolling friction using machinery parts are rolling. One part are moving on another part by rolling weight. Due to the friction less. So, rolling friction is very small. Rolling friction when created? Rolling friction when created? When one body is rolling on the surface, generated frictional force is called what? Rolling frictional force. One wheel is rolling on the surface. At that time, what generating? Rolling frictional force generating. rolling frictional force is proportional to normal reaction. Here also, this is also proportional to normal reaction. I am removing this proportional. At the time, what I am getting? Fr equals to mu r into normal reaction. What is the mu r? Coefficient of rolling friction. What is the name? Here mu is called coefficient of rolling friction. So mu s, mu k, mu r. In all of these, mu r is very small. Due to that only machinery parts constructed by rolling wheel. Even the radius also brings out rolling wheel because friction less in between the road and that. Otherwise, what happens? Heavy friction generating fuel waste happens. Similarly, friction is very useful and also advantages and some disadvantages. For example, we are holding one glass. How? In between the glass and our fingers, friction is there. Otherwise, it slips. Understood? One vehicle moving on the road, how? Some friction is existed in between the road and the tires. Otherwise, not possible to move. Some like this advantages. What are the disadvantages? Heavy friction. For example, we are taking rolling process only in the case of machinery parts motion. But in that case also, what generating? Some friction generating. Due to that, what happens? Machinery parts damaging, heat generating, like that happens. For reducing that, we are using lubricants. What is the name? Lubricants. What are the examples for lubricants? Grease, oil. These are reducing the friction. Similarly, polishing. We are polishing the surfaces. At the time also what happens? Friction reduces. But high polish, what happens? Friction more increases. Why? When we are polishing highly, at the time the surface is getting charges. In between the charges, what is there? Electrostatic force is there. At the time that is very powerful. So coefficient of friction increases. More than the one also comes in the case of rubbing process. So rubbing is enough. But heavy rubbing creates charges, heavy friction increases. Understood? So these are the advantages and disadvantages. Clear now? Similarly, we are using ball bearings in the motion of the machinery parts. Why? Inner wheel, outer wheel, in between that we are introducing steel spears. When inner wheel rotating depends upon the motion of the spear, outer wheel rotating. Rolling friction is less, it depends upon this concept only. Ball bearings create in the machinery parts motion. This is about friction. In this way, similarly, what about FMS value? FMS value is the maximum value. What about FS value? FS value is self-adjusting value. That may be equals to FMS. Sometimes maybe less than the FK also comes. You see? What about FS? Up to this FS. FS is equal to FMS. Here less. Here equal to FK. Here more than the FK. FS anyway changes. FMS fixed only. FS anyway changes. Equals to FMS comes. Equal to FK comes, more than the FK comes, less than the FK comes, because this is self-adjusting force. What about FK? FK also fixed. This must be less than the FMS. But you don't tell more than the FS, because above also what came? FS came. Below also what came? FS came. Because FS is self-adjusting force. That may be more than the FK, equal to FK, less than the FK, or equal to FMS. Understood now? FMS, FK value is fixed. But FS, this is the value like that not possible to tell because self-adjusting. Clear now? But FK is always less than the FMS. Is it clear now? This is about friction. Quick.